This video is going to talk about how to identify equivalent ratios. I'm going to show you 3 different ways to identify equivalent ratios. You might find that one of these ways works better for you, or that one of these ways doesn't always fit the situation. Go ahead, watch these 3 different ways. There will be one question at the end of this video that you're going to be asked to answer. So don't worry too much. If you see all these numbers being thrown up, there's going to be 6 examples because there will be 2 examples for each option. So the first option to identify equivalent ratios is to look at the unit rates. So first let's look at our example. Let's say there's a car A, that goes 20 miles in 5 hours. As you see, I have 20 miles and I have 5 hours. Car B goes 45 miles in 9 hours. As you can see, I have miles, miles, hours, hours, because we're talking about the same type of rate, so I'm going to keep those numbers the same. So, how do I look at this? Let's get this down to the unit rate. 20 miles in 5 hours. How can I simplify that to get it down to the unit rate? Well, I know that 5 goes into 5 and 5 goes into 20. So I'm going to divide by 5 over 5 to get this lower number down to 1. 20 divided by 5 is going to be 4. 5 divided by 5 is going to be 1. Car A can go 4 miles in 5 hours. When I look at car B, 45 miles in 9 hours, I know that I'm going to have to use a different number to simplify because 5 will go into 45, but it won't go into 9. So I'm going to simplify by 9 because I know that 9 times 5 is 45. So let's go ahead and simplify by 9 over 9. 45 divided by 9 is going to be 5. 9 divided by 9 is going to be 1. So, that didn't really help too much with the glare, did it? I'll go a little bit lower for the next problem. So, in this example, car A only goes 4 miles in 1 hour, and car B goes 5 miles in 1 hour. So you can see that the better car to have would be the car that goes 5 miles in 1 hour. Unless you're looking at avoiding getting to where you're going, then you want car A. Let's look at a second example of this. Let's go shopping, and let's go shopping for some shirts. You have 2 options at the store. You can either spend $21 on 3 shirts, or you have the option of spending $35 on 5 shirts. Now what we want to know is which is the better deal to take. So in order to figure this out, what we need to do is we need to look at the unit rates. So how do we get $21 for 3 shirts down to a unit rate? Well, we want to know how much we're going to be spending per shirt. How much will 1 shirt cost in this deal? And to figure this out, we're going to divide by 3 over 3. 21 divided by 3 is going to be 7. 3 divided by 3 is going to be 1. So in the first example, it's $7 for a shirt. In the second example, $35 for 5 shirts. We also need to get a unit rate. We need to get this 5 down to a 1. And to get 5 down to a 1, I need to divide by 5. Whatever I do on the bottom, I have to do on the top. So I'm going to divide by 5 over 5. 5 divided by 5 is 1. 35 divided by 5 is going to be 7. So you can see that it doesn't matter which of these 2 deals you take, you're still paying the same amount of money. You're still paying $7 for 1 shirt. Okay, so that was how to identify equivalent ratios with unit rates. Going into the 5-minute mark, if you're looking to come back, we're going to look at using equivalent ratios. So, in our first example, we have a swimmer. And this swimmer, I'm going to try to adjust this real quick so we have a little bit less of a glare. This swimmer can swim 5 laps in 8 minutes. And we'll call that swimmer X. Swimmer Y can swim 15 laps in 16 minutes. And what we want to know is this the same amount of time, or is one swimmer going faster than the other? And here's how we're going to check and see if these are equivalent to each other. So this 5 and this 15, how do you go from 5 to 15 when you're multiplying or dividing? When you're trying to compare fractions, how would you go from 5 to 15? Well, you would multiply by 3. 5 times 3 is 15. How would you go from 8 to 16? Would you also multiply by 3? Is 8 times 3 16? No, 8 times 3 is 24, which means, because you're only multiplying by 2 here and you're multiplying by 3 here, that is not a fractional one. That is not the same number on the top and the bottom. So this is not an example of an equivalent ratio. These two ratios are different from each other. Let's look at a different example. Can I go? Yeah, we can. Let's look at the example of, we're going to go back to shopping again. Let's say you can buy 6 DVDs for $90. If you can buy 6 DVDs for $90, there's another deal that says you can buy 3 DVDs for $45. And what we want to know is this the same deal, or are you getting a better deal on one versus the other? So here's what I'm going to look at. Same thing as up here. How do I go from 6 to 3 using multiplication or division? If you're saying I would divide by 2, that's the 3. I said 2. You said divide by 2, you'd be correct. Because 6 divided by 2 is 3. How would I go from 90 to 45? Well, I know that 45 is half of 90. So I would, again, divide by 2. And because I'm dividing by 2 here and I'm dividing by 2 here, I'm doing the same thing to the top and bottom. If I do the same thing to the top and bottom, then the ratios are equivalent. Okay, we have one more set of examples. And this is the way that I tend to use, because it will tell you which one's larger and which one's smaller, and it works every time. Other situations will work most of the time, or maybe if you do a little bit of guessing, this one will work all of the time. So we're going to look at cross multiplying. Let's look at an example of going to the store and buying some bread. You can buy 20 rolls for $5. Or you can buy 32 rolls for $8. Now what we want to know is this the same ratio or is it different? And when we compare ratios, I know that this video is getting a little bit long, and I know that comparing ratios and fractions can be really annoying. And when you get really annoyed, you tend to roll your eyes. And when you roll your eyes, and don't tell me you don't do that sometimes because you're a middle schooler, when you roll your eyes, you tend to look up. And when you look up, that's going to remind you of where you're going to put the number in this situation. Because when we cross multiply, we have to put the number up. So 5 times 32. we're going to take 5 and we're going to multiply it by 32. 5 times 2 is going to be 10. 3 times 5 is 15, plus 1 is 16. So 5 times 32 is 160. Now we're going to cross multiply the other way. 20 times 8. Well, I know that 8 times 0 is 0, and I know that 8 times 2 is 16. So we're going to get 160 again. And what you're going to notice is that I multiplied the number farthest away from the other number. So you see how I make that x there? 5 to the diagonal of 32, 8 to the diagonal of 20. When I do this, I get the same number up here. And if you get the same number, what's going to happen is these are proven to be equivalent. This is the same deal, 20 rolls for $5 or 32 rolls for $8. Let's go ahead, let's take a look at one more example. Alright, if I can go to the store and I can get 30 posters for $6, or I can get 40 posters for $9. The question is, which is the better deal? So here's what I'm going to do. I'm going to cross multiply again. 6 times 40. And I know that 6 times 4, 6 and 6 is 12. 24 is 240. Because 6 times 4 is 24. Plus that 0 on the end is 240. Now I need to do 9 times 30. 9 times 3 is 27, plus that 0 on the end is 270. You notice that I did not get the same number up top. And because I did not get the same number up top, these are not equivalent ratios. And in fact, this is the bigger fraction because this is the bigger number. But you need to be really, really careful to put your number up top and to roll your eyes when you do it because it'll help you remember. Because if I were to put the number on the bottom, the numbers would have been in the wrong spot and it would have gotten your answer flip-flopped. So don't do that. Okay, it's your turn now. On a student council, there are 12 girls for every 16 total students. On the Earth Day committee, there are 4 girls for every 8 students. The question that you're going to answer is the ratio of girls to students the same in student council and Earth Day committee, or is it different? Make sure you explain why.